Alright. Yesterday we did the simple converting to base 10, which we're kind of going to use a little bit eventually. Equations, we've got to introduce some things. If we have a similar base or similar log, it makes things a little bit easier. Then we get some tricky stuff. Like there's a number of different scenarios, and this is where word problems and that sort of stuff come in. All right. Sorry. So, solving exponential and logarithmic equations. We're going to look at some exponential ones that have, we call them common bases. When the bases are not the same, they get a little bit trickier, but not too big of a deal. And then we'll probably, just depends on time and whatnot, we'll either do all of type 1 and introduce type 2, or we'll go as far as we can. So there's 4 exponential equations. If we have a common base, solve the equations by getting a common base. And what we mean by that is a base of 2, a base of 3, or whatever those sorts of things are. Um, so simple, 2 to the x equals 32. Well, I can do that, 2, 4, 8, 16, 32. The answer should be 5, but to do it properly, 2 to the x, can I express 32 as a power of 5? Or a power of 2, sorry. 2 to the x equals 32. Once the bases are the same, and effectively it's not really canceling. Technically what you're doing is logging them and dividing. But 2 to the x equals 2 to the 5. I can cancel those, and therefore x equals 5. And that's easy to see. It gets a little bit trickier when we have these ones. Some of this is visual, some of this is knowing your powers. 9 and 27 are both powers of 3. So 9 is 3 squared to the x plus 4 equals 27 is 3 cubed. Well, I can make this a single exponent. Power to a power means multiply. 2 times x is 2x. 2 times 4 is 8 equals 3 cubed. Bases are same. They can go away. So therefore, we get 2x plus 8 equals 3. Two x equals negative 5. Negative 5 over 2. And we can put that in if we wanted to check. 5 divided by 2 is 2.5. Throw a negative sign on there. Plus 4 gives that. 9 to the power of 1.5 is bracket 3 divided by 2, bracket 27. So you can go back and check a lot of these, just like any equation. And just like any equation, we can kind of add the algebra steps. Well, I need to get my kind of the first ultimate step is isolate your exponential. And then you can do all sorts of stuff. So 16 to the 2x plus 5 equals 7. Well, that looks like it has absolutely nothing. Minus 5 minus 5. 16 to the 2x equals 2. Okay, that's a little better. 16 is a power of 2. It's 2 to the 4th. So the 2x, that's 2 to the 1. 4 times 2, 2 to the 8x equals, oops, sorry, 2 to the 1. 8x equals 1. X is 1 over 8, which something to the, well, that's to the quarter, makes a little bit of sense. Like it makes sense that that's a big base, that's a small base, that we need a fractional exponent. Same idea, it's just instead of an addition or subtraction, I have this business in front. Divide by 2, divide by 2. 5 to the x minus 3 is 125. That's a power. That's 5 cubed. Get rid of those. And then we go to grade 9. X equals 6. 5 cubed times 2 equals 250. We can do all sorts of different ones in this sense. Oh dear, a quarter to the 3x equals 64 to the 2x plus 1. 64 is a power of 4, but this has a quarter. Could I potentially try to work that out into a power of, what's the word I'm looking for? 4, or a quarter. Yeah, that would be a little bit tricky, but a quarter is 1 over 4 to the 1, which is 4 to the negative 1. So I'm going to do that. 4 to the negative 1 to the 3x. 64 is 4 4s are 16, 4 16s are 64, so 4 cubed. Negative 1 times 3x is negative 3x. 3 times 2x is 6x. 3 times 1 is 3. Bases are the same. Negative 3x equals 6x plus 3. The old Madame Hayes, numbers on one side, letters on the other. Oh, let's for fun, just because. Leave the 3 there, so subtract 6x, subtract 6x. Negative 9x equals 3. Divide by negative 9, divide by negative 9. X is negative 1/3. And that is, should, I mean, we can check it if we want. 4, 2 times 1/3 is 2/3, negative 2/3, plus 1 is 1/3. Yeah, that's going to work out. They both equal 4. 81 to the x equals 3. Well, that's 3 to the 1. 3 times 9 is 27. 27, so this is 3 to the 4 to the x equals 3 to the 1. Whoops. One. X is a quarter. The 4th root of 81 does equal 3. So we cancel these things out. I'm just going to really erase and redo this. What we actually do, so this is 3 to the power of 4x equals 3 to the 1. What we're actually doing when we do this is we're logging both sides, because the inverse of an exponential is a log. Log base 3 of this, well, I can bring 4x equals, well, and I'll do the other side in a sec, 4x times log base 3 of 3. Log base 3 of 3 to the 1. Well, I can bring the 1 down, or even if I don't have that, log base 3 of 3. This is 1. This is 1. Because the log base n of n is 1. 4x equals, because 4x times 1 equals 1. So that's technically what we do. We just take the log base, whatever we want. This one would be the log base 4. This one would be the log base 2, the log base 5, log base 2, log base 3. Whatever you need, if you log both sides, you pull the exponent down and everything kind of gets happy. Where this gets a little bit tricky is when the bases are not the same. So we have a couple, and we'll probably do some of these. Oh dear. 3 to the x equals 3 to the 25. Take the log. I'm just going to use log in general. Most people are going to use log base 10 because these are going to be numeric. We're going to be able to use our calculator. Technically, you could use ln. If you wanted to try to be tricky, you could use any base. But I have my exponential isolated. Log of 3 to the x, log of 25. Using my power rule, I move that down in front. X times log of 3 equals log of 25. Awesome. Now I know that's a number, that's a number. Divide by log 3, divide by, whoops, divide by log 3, those equal 1. X equals log of 25 divided by log of 3. 25 log divided by 3 log 25 divided by log of 3 equals 2.9 299 2.93, whatever you want to do there. So it's the same, technically it's the same thing that we do when the bases are the same, but we just have to show it because we have to use the numeric version. Over here, we have to isolate our variable. So 7 to the 2x minus 4 equals 30. Logging both sides. Log 30, whatever. Getting ahead of myself. Move the exponent down. 2x minus 4 times log of 7 equals log of 30. I would divide by the log of 7 to get rid of that ugly business. Those go away. 2x minus 4 equals. Now we're going to have some decimals, and it's going to be not as pretty. 30 log divided by 7 log equals 1.75. 2x equals 1.75 plus 4. Divided by 2. 2.875-ish. Because we know when we do that step, we actually get irrational stuff. 2.875 times 4, whoops, times 2 minus 4 is that. 7 to the power of 1.75 is that, times 3. Because of that rounding, everything is kosher. Same thing here. log x plus 2 times the log of 5 equals the log of 437. Pull out our handy dandy calculator. Now I gotta move it because I can't remember what the number was. 437 divided by 5. 3.777. Minus 2, minus 2, 1.78. Like all of the rest of these are just kind of little variations on a theme. This one here, if the base is e, what would we do? Well, I'm not going to log both sides. I'm going to ln both sides. Because the ln of e to the something, well, that's x minus 5 is the ln of, or the natural log of, I don't like that little blue dot there, 48. 48 O-N, score, 3.87. Could you log everything? Sure. The log base 10 of e is going to get a little bit messy. Add 5, x equals 8.87. Which one do I want to do first? Because we did that, we'll do 6 and then go back to 5 because it has a couple extra steps. E to the 2x plus 10 equals 50 minus 10. Isolate your exponential. We'll take the natural log. Those are going to cancel. The ln of 40 is 3.6. Wow. 8, 8, 8, 8, just because it's fun. 3.6888 divided by 2. That's kind of nifty. And the last one for today is we've got a couple of steps. I need to get rid of the 5, get rid of the 4, and then do my log. So I have to add 5, 4, 6, x plus 2 equals 120 divided by 4 divided by 4. 6 to the x plus 2 equals 30. Log both sides. Exponent comes down. That x plus 2 equals, well, log of 30 divided by log of 6, 1.90. x equals negative 0.1. So that's solving logarithmic or exponential things. The trickiest part is would be taking the log of everything. Solving logarithmic equations, we'll start that on Monday. We have a couple of different things. And now once we have this kind of concept, we can go back to the graphing and find our x-intercepts and y-intercepts for any particular thing, because we know a y-intercept is when x is 0, an x-intercept is when y is 0, and so on and so forth. So that's where we'll stop today. I may put some practice up later, but I'm not super worried about that. Is there any questions? If not, it's time for the weekend. Well, for me, my classes are done. Some of you guys might have other things.
Thank you.
You're welcome. Have a good weekend. Thanks.
Thank you. Bye.
Welcome. Bye, everybody. Whoa, what happened there?